Hello and welcome to Friday's second edition of Cracking the Cryptic, at least second edition, I hope. I'm hoping Mark has done a crossword video earlier. I don't know this because I'll let you in on a secret. I'm actually recording this in advance because I have a prior engagement on Friday for once, which means I can't record on the day. So I'm just going by the fact that I've asked Mark to do the crossword video on Friday morning, so hopefully you will have seen that. Especially if you're interested, of course, in our cryptic crossword content. But what am I going to be trying to do in this video? Well, I'm going to be trying to do a puzzle. It's called Counting Killers. It's by Yawnus. And we've had this recommended to us. I mean, I have to say, I love the rules to this. I've done a couple of puzzles this week with really short rule sets, but this is another of those. And it's just an incredibly simple rule, which is that if the digits in a cage sum to n, there are exactly n cages whose digits sum to n. So imagine those two summed to 8. There would be 8 cages summing to 8. Isn't that weird? It's like counting circles, but for killer clues. And I've done a couple of Yawnus puzzles on the channel in the past. I think both of those were little rinky-dinks on Killer Sudoku, and I remember enjoying. I think I did one back in around January 2026, so earlier this year. I do remember that one and liking it very much. I'm hoping I will enjoy this one too. I don't know how difficult it is. I forgot to look it up on Logic Masters. So I can't tell you. You'll have to judge somewhat by the length of the video, assuming this becomes a video at all. At least you'll be able to see how difficult I've found it. But we'll read the rules properly and fully together in a moment or two's time. Let me just think about a couple of other things. I've mentioned the crossword video earlier on. Over on Patreon, we have a brand new competition, which is called Alien Invasion. I know loads of you have been enjoying the puzzles there. They're a little bit easier than last month's, and the feedback we've had so far is that they are even more enjoyable, if possible, than last month's. So do get involved in that. We themed it to coincide with the fact that there's been all of these declassified papers in the US about alien activity on Earth. So we thought it was an apposite subject matter. And if you want to win the chance to come onto the channel and solve a puzzle and appear in a video, then that is the way to do it. Other than that, what else can I mention? ZETAMATH. We've got our new ZETAMATH app out. That is well worth checking out. That's available on all platforms. Puzzles by the great man. And birthday. I've got a birthday to do. Let me just find it. Now, okay, I'm going to go for Sarah, but it could be Sarah from the spelling. This is one of the things. If you're going to ask for a shout out, if there is any way of me getting it wrong, I probably will get it wrong. I think Sarah is most likely, but it is spelt without an H. So, it could be either way. It really could. I'm going to stay with Sarah. And if it is Sarah, then apologies. But Sarah, your boyfriend Noah wrote to me and said that I think the two of you stumbled across the channel and have stayed for the logic. Why wouldn't you? So many happy returns. I don't even know exactly when your birthday is. I just know it is this week. Noah's email didn't actually give me the day, so I'm sorry if I'm a bit late with this. But I know you've just finished your second year of law school, and I can tell you that Noah is so extremely proud of you. So very well done on getting through that. I think the two of you have been together for 7 years, or will have been together for 7 years soon, in the coming weeks. So I hope on your 7th year anniversary there is some chocolate cake, and I hope today there is some very, very heavily iced chocolate cake as well. Many, many happy returns. That's all the news. Now we can do some solving. Shall we have a go at Counting Killers by Yawnus? Let's read the rules properly, and although they're not going to take long to read, we've got normal Sudoku rules applying. So we're going to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. Digits cannot repeat within a cage. So in normal Killer Sudoku, in fact, very few of these cages could have a repeat in them anyway because of normal Sudoku rules, but I guess that one could have done, maybe that one. But anyway, we can't repeat digits anyway, it says we can't. And as I said before, if the digits in a cage sum to n, there are exactly n cages whose digits sum to n. And that is the end of the rules. Do have a go. The way to play is to click the link under the video as usual, but now I get to play. Let's get cracking. Now normally in a counting circles puzzle what I would do is I would count the circles. So today I suppose I've got to count the cages, do I? Oh, look at that. You can double click. Yeah, I see. So if you double click on a cage, I think it highlights not all cages of the same shape, but all cages of the same size. So double clicking on this three cell cage here also highlights other 3 cell cages. So let's just give these colors and then we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think there are 15 purples. 16, 17, 18, 19. Oh, hang on. 16, 17, 18, 19, 20, 21, 22. I might just double check that, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've got 15 for the purples twice. 1, 2, 3, 4, 5, 6, 7 for the greens. Okay, so we are at 22, I think. So the cage totals. So we've got sort of 22 to play with, which could be... the thing is, you could do that in loads of ways, actually, couldn't you? Because the minimum size of a 2-cell cage would be 3 if it was a 1-2 pair. So you could have... If you had a 1-2 pair, you'd have 3 cages summing to 3. But you could also have, a 3-cell cage. Oh, well, okay, you can't add these to 24. In fact, the 3-cell cages, there are only 7 of them, can't add to more than the maximum for a 2-cell cage. The maximum for a 2-cell cage would be an 8-9 pair, which is 17. So imagine we tried to claim, we could make this 3-cell cage add up to 18. Well, then there would need to be 18 cages adding up to 18. And you couldn't make 18 in more than 7 of these cages because the 2-cell cages could only add up to 17. So we know actually the highest total is 17. And the lowest total is 3. And we have to somehow do this so that 22 cages are used. So the way my brain is going is something like we could have a 985 or something. So you could have it, because 9, 8, and 5 I know add up to 22 for some reason. But that would mean there were 9 cages adding up to 9, 8 cages adding up to 8, and 5 cages adding up to 5. Or you could have 9, 6, 7. That would also be true. Or you could have, but you could perhaps have no, you've got to be a bit careful here. I was going to say 12 and 10. So you could have 12 cages adding up to 12 and 10 cages adding up to 10. But I think we are going to have to be careful because of this box, and actually that box as well, which have exactly the same sort of geometric property. They have a 3-cell cage and then 3 2-cell cages. But I'm thinking the secret might be relevant there. A secret is something I share with only my very favourite people, of course, but if you're watching this video, you're definitely one of my favourite people. So I will share the secret with you. The secret of Sudoku is that any box of a Sudoku, because of the rules of Sudoku, contains the digits 1 to 9 once each. And if you sum the digits 1 to 9, you get 45. So whatever combination of cage totals we use in this puzzle, they sort of have to be capable of summing in combination to 45 somehow. So 12 and 10 won't work, because even if we had sort of 3 12 cages, then we'd need 9 more, wouldn't we? 3 12 cages would be 36. we wouldn't need 10. So, in fact, this is interesting. No mocking me. It's all been done before. All of the mocking, all of the nerd calling me a nerd and a geek, and it's all been done. I am immune to it. What I was going to say is that 985 or 967 won't work because the biggest cage total would then be 9, and even if all 4 of those cages sum to 9, that would only get us to 36, where we know the box total is 45. So we definitely need... Okay, well, I can get rid of more from this. So 10 won't work as the highest... If 10 is the highest total available for a cage in this puzzle, even if all 4 of these cages sum to 10, you'd only get to 40. That's not enough. We need to get to 45. 11 won't work. That would get us to 44. So the absolute minimum size of the highest cage total is 12. 12 could work. If you had three 12 cages and a 9, yeah, see, that doesn't work, I don't think. But the reason that doesn't work is truly strange. And it might not be true either. The basic reason I was thinking 12 wouldn't work is if we had 3 12 cages and the 4th cage summed to 9, that would seem to work. And then we'd have 12 12 cages in the puzzle, 9 9 cages in the puzzle. But we were left with 1 cage because there are 22 cages altogether. 12 plus 9 is 21. So there would be 1 cage that should add up to 1. But you can't make a 2-digit sum add up to 1. So there couldn't be such a cage, so it wouldn't work. But I'm just pausing there because is it possible that in this box, for example, rather than having 3 12 cages, could you only have 2 12 cages? If you had 2 12 cages, that's going to be awkward. But that's not the same thing as it being impossible. I don't think it would work. Because, and this isn't going to get, this is a bit hand wavy. Let me just think about this. There might be a way of actually proving it demonstrably. If you had 2 12 cages, those would sum to 24, which means the other 2 cages, which could be these 2, we don't know, but they would sum to... Those cages would have to sum to 21 in order for the box to be full of digits that sum to 45. Now 21 is odd, so you couldn't do that 21 with just 1 cage. You'd have to do it with 2 different cages, an odd sum and an even sum that wasn't 12. But you'd have to do that in such a way that those 2 sums summed to no more than 10, because the 12 cage is going to... The fact that there are 2 12 cages means there are 12 12 cages, so I've only got 10 cages left to cope with. And there's no way that can work. If you had like a 7 cage and a 3 cage, for example, that are meant to... Those 2 cages are meant to sum to 21. It's just total nonsense. You can't get anywhere near. In fact, okay, so is that a generalizable point? Are we saying that whatever the biggest cage is in this puzzle, there have to be 3 copies of it in these boxes. Because if there were only 2 copies of it, I'm not sure. I'm not sure I am going to say that. Oh, this is actually quite awkward, isn't it? If you only had 2 copies of it, so whatever the biggest cage is, let's say it was 16. So if you had 2 16 cages, well, 16 is difficult as well, because 16, you couldn't put 16 into 2 2-cell cages in the same box, because the only way of making 16 in a domino is with a 7-9 pair. So this would have to be a 16, and one of these would have to be a 16. And they would sum to 32, which means the other 2 cages would have to sum to 13. Yeah, and you couldn't do that because you'd only have 6 cages spare. Yeah, there's no way you can do it. It's actually, it's very constrained, actually. I'm not sure 15 will work either. So if we had 15, and we had 2 15 cages in here, again, they're always, if we're saying that there isn't a triple, i.e. if we're saying that the biggest cage total used in this box is not used 3 times, let me just think this through. It's clearly not possible. So I'm not articulating this very well. I know I am not. I'm trying to get my head around it. A, B, C, D. So let's do this diligently. Can all 4 cages be different? No, because A plus B plus C plus D would equal 45, and that would mean there would be 45 cages in the puzzle. There are not. There are only 22. So that's total and utter rubbish. Now, what I'm trying to prove at the moment is that if, say, we had 2 cages the same, and these are the biggest value cages, it won't work. And we can see that double A will always give us an even total for those digits used, because it's going to be 2 lots of A. So even if A itself is odd, 2 lots of A will always be even, which means that these B plus C will always sum to an odd number, and therefore one of these is odd and one of these is even. But if A was, say, 15, then we've only got 7 cages free, because we've got 22 cages altogether. 15 are used for the 15 cages. So these can't add up to more than 7, and yet have to add up to 15. Yeah, okay. And yes, so it would get closer if you could do double 7. But you can never do double 7. You could never do that, for example, because this would 2B plus 2A would not be odd. It would always be an even total. So this would get you very close if you did 15 and 7, say. That would get you very close, because you'd have 2 lots of 15 for 30, 2 lots of 7 for 14, and that 44 is close to 45, but it's not exactly right. So you can't use double. It just won't work, I don't think. For double 14, 28, it's a worse problem. These have to add up to 17. So I now believe it is true to say that in some combination there are, and it might be that these 3 all add up to A. It might be those 3. We don't know which 3, but there are 3 instances of sum total in box 9 and box 7 for that matter. Now, okay, so having concluded that, what is A? A is not 15, because then it just won't work. The final cage will be 0. So A is 14 at most. And if A was 14, 3 14s are 42, this would be B would be a 3 cage. And well, that's interesting, because that would mean there could be a different cage again. So you could have a 14 cage, a 3 cage, that adds up to 17. So there would also be a 5 cage as well. So the 3 cages used would be 14, 3, and 5. Now, but is there another way of making 5, 1 and 4? No, you can't. We can't use 1, can we? So this 5 is indivisible. So we couldn't make the 5 a 1 cage and a 4 cage, because 1 cages don't exist in the puzzle. So it would be 14, 3, 5. Now, would 13 work? If we had 13, it would be 39, and this would be a 6 cage. But we need overall 22, so we'd have another 3 cage. If 13 is the biggest value, we'd need a 3 cage, and if 14 is the biggest value, we'd need a 3 cage. That's weird. Okay, and if 12 was the biggest value, then we'd have 36 here. This would be a 9. This is the one I don't think works. This is what got me thinking about this in the first place, because then the final cage would be a 1, and we can't have a 1 cage, and we know 11 is too small. So we're either in a world where we've got 14 as the big digit, or 13 as the big digit, or not the big digit, but the big cage total. And there are definitely in this puzzle 3 cages that sum to 3, and therefore they are 2-cell cages, because you can't make a 3-cell cage sum to 3, and they are a 1-2 pair. It's going to be something to do with this pointing at this, isn't it? There are going to have to be 2 ways of making this. I don't know how to do this. So if it's 14, you are using a 3 total in the box, in one of the 2-cell cages. So let's look at this one, because I've noticed something else about this. If we're looking at this one, we know that this cage, or this box, this 3x3 box, and this 3x3 box are made up of 3 14 cages and 1 3 cage. Well, the 3 cage is always going to be a dominoed cage. So one of these will be a vertical 1-2 pair, which means neither of these could be a horizontal 1-2 pair. Because if this was, say, horizontal 1-2, which one of these is vertical 1-2? None of them could be. So this would be a 1-2 pair, and those would be 14. So those would be 5, 9, and 6, 8 in some order. That's it. That doesn't work. This is brilliant. It's absolutely brilliant. Right. So this doesn't work for this reason. It is what I said about these strings, that string and that string. Because we have to hypothecate one of the 2-cell cages to be a 1-2 pair, the other 2 2-cell cages in these boxes are going to sum to 14, which forces their composition. There's only 2 ways to make dominoes sum to 14 in Sudoku: 5, 9 and 6, 8. Now what that means is that the 3-cell sums are going to be 3, 4, 7, and this is going to be 3, 4, 7, and that cannot work, because this cell is not allowed to be 3, 4, 7 if those 3 are 3, 4, 7. So we can get rid of this one. That's not correct. This is brilliant, isn't it? Now that does imply, though, that this has a solution, which if it doesn't, I've made an error. It's better immediately in that this 3-cell cage is not appearing in here, because we're going to have 3 13 cages and a 6. Now I don't know whether the 6 cage is going to be in a 2. Could it be in the 3 cell cage? Let's think about that for a moment. Okay, no, I can immediately see it can. That's all. Okay, well that suggests it will work, because the fact that you can, oh no, I'm not sure actually. Maybe if they both have to be 1, 2, 3 cages, that won't work. That would be terrible. I mean, I can see 1, 2, 3 would work with this being the 6 cage, because these could be 4, 9, 5, 8 and 6, 7 in some order. So the only way, so we need, okay, so what we need to do is to find a way where if is to have this not be the 6 cage. So one of these needs to be a 6 cage so that we can change the composition of that string. So let's think about that. If that was 2, 4, could you do it? Then you couldn't use 9 in these, because these would be adding to 13 and 9 would require a 4. So 9 would move over here. So this would be 1, 3, 9. Yeah, okay, that's good, because that does work. Because then you could have a 5, 8 and a 6, 7 into these, and it works. I wonder if 1, 5 would work as well. If we have 1, 5, then we can't use 8 in here. So this would be 8, 2, 3, because it couldn't be 8, 1, 4. Yeah, and that works as well. So you'd have 4, 9 and 6, 7. That's okay, that's weird. I mean, this is actually quite amazing. But what we've just learnt is, I believe, that we have just learnt, let's try and summarize it in a pithy manner, that the 22 cages in this puzzle are 13 cages, 6 cages, and 3 cages. But in these 2 boxes, we're not using 3 cages. The three sum cages. We're using 3 in each case. We're using 3 13s and 1 6. And that's going to allow these to be different, so that we won't have a problem. Okay, and what that's going to give me is a pencil mark, because in both the variants in all of the variants we just looked at for how these boxes could work, there was always a 2-cell 6, 7 cage, and therefore that is a 2-cell 6, 7 cage, because if I put the 2-cell 6, 7 cage in either of those cells, it would clash with what must be a 2-cell 6, 7 cage in box 7. This Yawnus this is really quite amazing. So that is a 6, 7. Now, what does that mean? Oh no. I don't know, actually. I'm really not sure. Can I use that somehow on this box? Do they have to be 2, 3, 4, 5, 6, 15? Yeah, okay. This cage and this cage are also 13 cages, those ones there. And the reason I know that is you might say, oh no, they could be a 1, 2, 3 triple. Well, but the problem with that is, if this was a 1, 2, 3 triple, what would this one be? It would have to be a minimum of 4 plus 5 plus 6, which is 15, which is too high. The highest cage is a 13 cage. So those are both 13 cages, which is 26. By the secret, therefore, those add up to 19. So if that was a 6, no, that wouldn't work. So this is also a 13 cage. Let's Let's make... Okay, maybe we change the colouring. Yeah, okay, I'm going to change the colouring. Sorry about this. I'm going to say a yellow cage is a definite 13 cage. And the reason that this is definitely a 13 cage is that those three sum to 19 by mathematics. So imagine this was a 6 cage. The maximum value of those would be 2 plus 3, which is 5, which means this would be a 14. I can't put 14 in a single cell. So, so those are 19, and those are 13. So the difference between these two is 6. With, so if 13, if that was a 1. So yeah, with this being bigger. So this is a 7, an 8, or a 9, and this is a 1, 2, or a 3. If this is a 1, this is a 7. If this is a 2, this is an 8. Let's explain that. So imagine this was a 2. These would add to 11. So this would need to be an 8 to make the maths work. So these are always 6 apart, with this being bigger. Wow. Okay, that's not good. That is not good, is it? So how on earth do we take that forward then? I've got a clue. I think, okay, I'm going to have to go back and think about what these 3-cell strings can be. Because I think there were 3 different options. 1, 2, 3, I remember that as being an option. Where should we write them? Up in the corner here. You could have a 1, 2, 3 if it was a 6 cage. But if these were 13 cages, it depended what the nature of the 6 cage was. If the 6 cage was 5, 1, so when we did 5, 1 there, then we had to put 8, 2, 3. So 2, 3, 8 was one of them. And if the 6 cage was 4, 2, then 9 got invested in there. So that would be 1, 3, 9 to give us 13. So these cages, which I don't know are 13 cages, but I know the digits selected for them are from quite a narrow selection of digits. 1, 2, 3, 8, 9. So 4 and 5 in row 7 have to be in the middle. Can that be 4, 5? No. 4 plus 5 plus 3 is 12 only. So this digit is 4 or 5. Let's just recapitulate that quickly. In this row, what I'm saying is this cage and this cage are only selectable from these digits. So 4, 5 in this row are in the middle section of it, but this can't be 4, 5 pair because the yellow cage is meant to sum to 13 and won't. So this is a 4 or 5, and one of 4 and 5 is in there. Only one of them, and not 6 or 7. But we need a big digit there, don't we? It's nearly very difficult. Oh, hang on, we can't even use actually, hang on, how am I going to do this? I can't actually find a way to do it in my brain. Bad brain. Hang on, I'm so sorry. What's going on? Why doesn't my brain want to? My brain doesn't want to compute this at all. These add up to 13. Yeah, I tell you the simple way to do it is you can't put 5 in there. The reason you can't put 5 in there is that the other 2 digits would have to add up to 8. And therefore they would need to use either 5 again, which they can't, you can't repeat 5 in the box, or a 6 and a 7, neither of which can go in there. Because the way to get to 8 in 2 digits is either 5, 3, 6, 2, or 1, 7. So I don't think 5 is in there. That's given me my first digit, which is a 5 here. And 4 is in here then, but I'm not even sure 4 can work. So the other 2 digits add up to 9, with this being 1, 2, or 3. Oh, 1, 8. 1, 8 would work. Oh, that's such a relief. My brain, for some reason, couldn't compute a way of it working. But if this was 1, that's the only way it works. Because 4's in there, so the other 2 digits add up to 9. So they're not 4, 5. They can't be 6, 3 or 2, 7. They have to be 1, 8. So 1, 4, 8. This is now a 7 because we said these two were 6 different. These 2 digits are not, well, this is a 13 cage, so these are adding up to 8. They're 2, 6. They're not 1, 7, they're not 3, 5. So these digits are 1, 3, 9, 1, 3, 9. So we can put the 1 in. And this is a 3, 9 pair. We've actually got somewhere at last. Okay, do we get rid of... Well, no, let's be careful here. Let's be careful. Okay. It's nearly good, isn't it? This one now can't be 2, 3, 8. Because of the 8 in here. So this is either 1, 3, 9. It's definitely got 1 in it. It's either 1, 3, 9 or 1, 2, 3. It's still being recalcitrant, isn't it? Oh, but hang on. No, I can get that digit though, just by maths in the row. Oh no, I can't. No, I can't, because I don't know whether this adds up to 6 or 13, but I can probably limit this. Right, let's do maths. We know the whole row adds up to 45. These add up to 17. They add up to 13. That's 30. So these add up to 15. So if this was 13, this would be a 2. And if this was 6, this would be a 9. That's annoying. That's annoying. So there's 2 ways that would work. Can this be 9, 3, 1? This pencil mark is not preventing that. If this was 9, 3, 1, then oh, I've just seen something else I could do. But if this was 9, 3, 1, we would know the order. One of these would have to be a 6 cage, and it would have to be 2, 4. But here's the other thing I've just noticed. 7 in this box by Sudoku is in one of the bottom 3 cells. Now we know there's a 6, 7 in one of these, so the 6 is above it. And that corrects this digit. Look, that's got to be 2 and that's got to be 6. Now, if you're saying that doesn't do anything, Simon, oh, well, no, I've got something else for you then. The 5 here is down here somewhere. Now, 5 could have gone with 1 to make 6, but it can't because the 1 has to be up there, apparently. I can't remember why we thought this had... Oh, it had to have 1 because of the options here. So the 5 here is going with an 8 over here. So 5 and 8 are a pair. Down there somewhere. And 4 is appearing down here, either with 9 or with 2, depending on what this is. Oh, that's annoying. Oh, that is annoying. Okay. So, how do we do this then? I haven't got a Scooby-Doo. I haven't got a Scooby-Doo. Okay, I'm going to go further afield. That cage I can do. In fact, I'm going to make it yellow. Because it can't... If we look at the options, we've got 13 cages, 6 cages, and 3 cages. This can't be a 3 cage because it can't be 1, 2. It can't be a 6 cage because it can be neither 2, 4 nor 5, 1. So it has to be a 13 cage, and it's not 5, 8 or 6, 7, so it is 4, 9. And the rest of this, oh, so 1 in the column can be placed. So this could be a 3 cage. That's so annoying. That's so annoying. But these digits are now known. They are 3, 7, 8. That's very important for the following reason. What's this cage? That's not a 2, 1 cage. This is also a 13 cage, because this one can't be 1, 5, 2, 4 or 1, 2. So that's a 13, and it's not 4, 9, and it's not 6, 7. So that one is 5, 8, and that gives us some more joy. 8 and 4 can go in. 3 can go in here. So now I get these digits, which are 2, 6, 7. Now these digits are 5 and something, 4, 4, 5 pair. Now, okay, this one can't be 5, I'm going to claim. If this was 5, this would be either a 6 cage, which would require a 1 here. Why is my phone buzzing? Let me just check. Politics. I don't know. Or this would be an 8, which it can't be. So that's got to be a 4. That's got to be a 5. This is either a 2 or a 9, depending upon whether this is a 6 cage or a 13 cage. And this cage, this is either a 1 or an 8. And that's, I don't think we can do that. So these digits are 2, 9, and 6. It's a most peculiar puzzle, this, isn't it? Okay, I'm going to get rid of this now and hope I can remember. We're only dealing with 13 cages, of which there need to be 13, and I've found 5 so far. 6 cages. Wow, how do we do this then? 3 has to be over here, look. Yeah, okay. I should have got that before when I was looking at the options for those. But these are either 1, 3, 9 or 1, 2, 3. So that's the full panoply of digits. And 4 is definitely down here, but I don't know whether it's with 2 or 9. Six is up there. Do I know if I knew that this one was... I don't know how we're going to do this. I really don't. I'm trying to figure it out. Oh, hang on. I've got something. Did I work out one of those was a 5, 8? I did. So these... that's it. I've done it. Right. One of those is a 5, 8. No idea which one. But that means neither of those can be 5, 8. Which means that... well, it means lots of things, doesn't it? It means I have to split up the 5 and the 8 in this box somehow. So, and I can't put 8 in here at all, because 8 cannot sum to 6 or 3. So it would be forced to sum to 13 with a 5 and break whatever happens over there. So in fact, 8 has to be in this string, which certainly can't go with 9. So this is 2 and a 3, 8 pair. which means that 1 is in one of these along with 5, adding up to, oh, this is good, adding up to 6. And this is a 4-9 pair. There we go. Now that's doing things. So 9, 3, 3, 8. 8 is now not on the bottom here. So 8 is above and 5 is below. In fact, we can get rid of the corner marks now. This is 4, 6, 8. This is 1, 3, 9. And this is 5, 7, 2. Yeah, so there is a vertical 2-4 pair in column 7. It's quite brilliant, this. It's difficult, I think. Oh, that's a 1 now. Okay, so that needs a new colour, because that's a 6 cage. This is a 13 cage. This is a 13 cage. That is a 13 cage. That is a 6 cage. That's a 13. That one we don't know. Now, what have we got down here? We have got a 2-4. So we've got 2 13 cages, being the 8-5 and the 6-7. So how many 13s have I now got? 1, 2, 3, 4, 5, say. 6, 7, 8, 9, 10, 11. I've got 11. And I could have 12 if that's one. I've not found any 1-2 cages. But that could be one. That can't be one, actually, that one there. Okay. Where are my 1-2 cages in this puzzle? That's, I think, a legitimate question. I can't make this a 1-2 cage and this a 1-2 cage. That clearly won't work. Those 3 digits would only be selected from the digits 1 and 2. So I can have one of those. I could have that one. So I could have one of these, that one. Which other one? That can't be. That's 3 cells, can't be. That 3 cells can't be. And this can't be a 2-1 cage. So I don't know about that one. I don't know whether it's a 2 here or a 1-2 pair there. But I do know this is a 1-2 pair. And I know this is that's a 1-2 pair. So that gives me a 1 and a 5 here. So what does that do? Maybe nothing, maybe something though. 2 is in those cells. And 2 can't go there because then this would be a 1. So 2 is in one of those cells. This has become 6 or 7. Okay, here's an interesting point, I think. I think I now know where the last 2 13 cages are. This cage can't be a 1, 2, 3 cage, so it can't add up to 6. It obviously can't add up to 3, so that's a yellow cage. Now, what about that one? That can't be a 6 cage. 3 here would require a 1-2 pair, which doesn't work now, so that's definitely a yellow cage. And I think I've got all the 13 cages I'm allowed now. I'm going to double check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 2 of these. That's 13. So this is not that's got to be a 6 cage. That's got to be a 6 cage. One of those is a 6 cage. And if this is a 6 cage, it's got to be 2, 4, look. So that's 2, that's 1. This isn't a 1. This is a 13 cage. So, oh, that's beautiful. Yeah. How could this be 8 or 7? This domino would add up to 5 or 6. It can't. With the minimum these could add up to is 7 if they're 3 and 4. So that has to be 3. These have to add up to 10, without using 3, 1 or 2. So they have to be 4, 6, and I know the order. This is so clever. So that's 8 now. That's 5 to make 13. One of these is 6. Oh, look, that's 2 now. So that's 2, that's 4, that's 6, that's 7. And suddenly we've just filled in a whole load of the puzzle out of nowhere. This is not 2. So the 1, 2 pair is not here. It must be this one. So that earns its stripes as being entirely green. This therefore has to be it has to be a 1, 5 pair adding up to 6. It's the only thing it can be. This is a 1 now. And I think we're close to forcing this to be a Sudoku puzzle, which is an outrageous thing we might have achieved. That's a 9. The way we're going to force it is by getting this. And if we know the composition of this, we would be, well, okay, I do know the composition of that. It doesn't have a 1 or a 2 in it. It doesn't have these two, can't be 1 or 2. This can never be 1 or 2 either. So how do you make 3 cells add up to 13 if they don't involve 1 and 2? There's only one way. 3, 4, 6, I think. And in fact, the 4 is known, so that's 4. This is 3, 6. We know the order of that as well. So 6, 7 go in. Now, these are a 7, 8 pair. This is 6. This is 7. This is 4. This is 9. Beautiful. Right. So what do we need in column 9? 2, 5, 8. Where's 2? It's got to go there. There's a 5, 8 pair left to place, but that gives me a 5, 8 pair in row 1, look. So 3, 7, 3, 6, 7 into those digits. 6 we can place. 6, 7, 3. And that's the 3 in the corner. That's 3 in the corner. That's 3 in the spotlight, losing its religion. Okay, so those go in. 9 goes here. 8 goes here. That's just Sudoku. 8, 5, 5, 8, 8, 7, something. 3 maybe? That look right? I think so. This column needs a something. Technical term for a 5. Now these digits are 7, 8, 9, so we can put the 8 in and the 7, whoops, and the 9. These digits are 3, 5, 3, 5. We need 6, 7, 9, so we can put the 6, 6, 9, 9, 7. That seems to have to be 8. And if we haven't made a total Horlicks of this, we can put 7 and 9 in. And I reckon that's right, because the logic was just gorgeous, wasn't it? How long's that taken? 53 minutes. It's very clever. You really have to, or I really had to think about these boxes and how they could possibly work. And the fact they've got different ways of working does not make it easier. And there may have been a mathematical way we could have got to, what was it, 13, 6, 3 more quickly. In fact, let me just check it's right. Yes, it is right. That's a relief. But it's a beautiful puzzle, really interesting. Oh. Hang on. We have not finished. But now we probably have. Let me know in the comments how you got on with it. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.